Schizophrenia is a serious mental illness. It affects how a person thinks, feels, and behaves. People with schizophrenia may seem like they have lost touch with reality. This can be distressing for them and their loved ones. The illness affects about 1% of the population. Scientists believe that imbalances in brain chemicals, such as dopamine and glutamate, play a role. Structural changes in the brain have also been observed in some individuals with schizophrenia. While the exact causes of schizophrenia are still unknown, research suggests a combination of genetic and environmental factors. Genetic predisposition, early childhood experiences, and exposure to viruses are among the factors being studied. Antipsychotic medications are commonly prescribed to help manage symptoms. These medications work by targeting specific brain chemicals. Research continues to explore new medications and therapeutic approaches for managing this complex disorder. The phrenic nerve plays a vital role in our ability to breathe. It originates in the neck and travels down to the diaphragm, a large dome-shaped muscle that separates the chest cavity from the abdomen. The phrenic nerve acts like an electrical cable, carrying signals from the brain to the diaphragm. These signals control the rhythmic contraction and relaxation of the diaphragm, which is essential for breathing. When we inhale, the diaphragm contracts, creating more space in the chest cavity for the lungs to expand. When we exhale, the diaphragm relaxes, allowing the lungs to deflate. Without the phrenic nerve, our ability to breathe would be severely compromised. Its intricate connections within the nervous system highlight its importance in maintaining our overall well-being. The diaphragm, often associated solely with breathing, plays a much larger role in our overall health. It's the primary muscle responsible for respiration, contracting and relaxing to facilitate airflow. The diaphragm's movements impact our lymphatic system, crucial for immune function and waste removal. During inhalation, it creates a pressure gradient that helps pump lymphatic fluid. This action flushes out toxins and maintains fluid balance. The diaphragm massages our organs, promoting blood circulation and aiding digestion. Deep breathing techniques activate the parasympathetic nervous system, promoting relaxation and reducing stress. The human brain, with its intricate network of billions of neurons, remains one of the most complex and enigmatic structures in the known universe. While classical neuroscience has made remarkable strides in understanding the brain's anatomy and function, some scientists believe that a completely new framework may be needed to fully grasp the brain's extraordinary capabilities. This is where the quantum brain hypothesis comes in. This intriguing, albeit controversial idea proposes that quantum mechanical phenomena might play a role in how the brain processes information, forms memories, and generates consciousness. While some scientists believe that quantum phenomena could explain the brain's remarkable computational power, others remain skeptical. If proven true, it could revolutionize our understanding of consciousness, memory, and the very nature of reality itself. To understand the quantum brain hypothesis, we need to delve into the strange and counterintuitive world of quantum mechanics. Unlike classical physics, which governs the macroscopic world we experience every day, quantum mechanics describes the behavior of particles at the atomic and subatomic levels. One of the most bizarre aspects of quantum mechanics is the concept of superposition. In the quantum realm, particles don't exist in a definite state until they are measured. Instead, They exist in a superposition of all possible states simultaneously. Another key quantum phenomenon is entanglement. When two or more particles become entangled, their fates become intertwined, no matter how far apart they are. These concepts have profound implications for our understanding of the universe, including the possibility that they might play a role in the workings of our own brains. Could there be a connection between the phrenic nerve, responsible for our breath, and schizophrenia, a complex mental disorder? The phrenic nerve plays a crucial role in regulating breathing, which in turn influences oxygen supply to the brain. Some studies have observed abnormalities in breathing patterns and diaphragm function in individuals with schizophrenia. While these findings are preliminary, they raise the intriguing possibility that impaired phrenic nerve function could contribute to the physiological underpinnings of schizophrenia. Dysregulation of the autonomic nervous system has been implicated in various mental health conditions, including schizophrenia. The classical view of the brain sees it as a complex biological computer. Neurons communicate with each other through electrical and chemical signals, forming intricate circuits that process information, store memories, and generate behavior. The quantum brain hypothesis proposes that quantum mechanical phenomena might play a role in brain function. This perspective suggests that the brain's computational power might go beyond the capabilities of classical computers. It's possible that the brain operates on both classical and quantum levels, with classical mechanisms governing the large-scale organization and function of neural circuits. Quantum phenomena might contribute to the brain's remarkable information processing capabilities. Bridging the gap between the classical and quantum perspectives on the brain is a formidable challenge. It requires integrating knowledge from diverse fields, including neuroscience, physics, chemistry, and computer science. One promising avenue of research involves exploring how quantum phenomena might manifest within the brain's biological structures. Some scientists are investigating the potential role of microtubules, tiny tube-like structures within neurons, as potential sites for quantum coherence. Others are studying the behavior of ions within neurons, exploring whether quantum tunneling might contribute to neuronal signaling. These models aim to bridge the gap between the microscopic world of quantum mechanics and the macroscopic world of brain activity. Bridging the gap between classical and quantum perspectives on the brain is an ongoing journey of discovery. Connecting the dots between schizophrenia, the phrenic nerve, the diaphragm, and quantum physics requires a speculative leap. Disruptions in phrenic nerve function, by affecting breathing patterns and oxygen supply to the brain, create a cascade of physiological changes. These changes could impact the dynamics of neuronal networks, potentially contributing to the cognitive and perceptual disturbances observed in schizophrenia. What if quantum phenomena play a role in how the brain processes information and generates consciousness? Could disruptions in the brain's delicate quantum processes, influenced by phrenic nerve dysfunction, contribute to the altered states of consciousness and perception characteristic of schizophrenia? By connecting seemingly disparate dots, we can open up new avenues of inquiry that might lead to a more comprehensive understanding of complex phenomena like schizophrenia. The exploration of potential connections between schizophrenia, the phrenic nerve, the diaphragm, and quantum physics represents a frontier of discovery. By embracing the unknown, asking bold questions, and challenging conventional boundaries, we foster an environment of intellectual curiosity and scientific exploration. While the answers might not come easily, the pursuit of knowledge, driven by a thirst for understanding, is what propels scientific progress. As we venture deeper into the mysteries of the brain and the universe, we must remain open to unexpected connections and embrace the beauty of complexity. The journey might lead us down unforeseen paths, but the pursuit of knowledge is a journey worth taking,